Next, we're going to look at box plots, or box and whisker plots as they're also known. These are based on the 5-number summary. They're very simple and easy to draw. A box plot contains a title. It has an axis with a label on it and a scale. Scale is usually uniform, but it could be logarithmic or some other format, but typically uniform. And then we have a box in the middle of the graph. It extends from the first quartile to the third quartile. The median is placed inside the box as a vertical segment like that. And then we extend whiskers out from the first quartile to the minimum and from the third quartile out to the maximum. And that's basically what you do if there are no outliers in your data set. If you have outliers in your data set, you probably want to use a modified box plot, which shows those outliers in the graph, and it's a lot easier for people to understand when you do that. What you do in the modified box plot is you extend the whiskers out to the most extreme values that are not outliers, and then the outliers are marked separately. So in this one we have a title, we have an axis with a label and a scale. This box extends from the first quartile to the third quartile with the median in the middle somewhere. The minimum is over here on the left, and since this distance from Q1 to the minimum is about the same as the IQR, there are no outliers down on this end. But over here, if you take 1.5 times the IQR, that would extend out to about here, and the highest value in this data set would be an outlier. I extended this whisker out to about here, presuming that that's the highest value that is not an outlier in the data set that we have. Here are a couple of examples. We looked on a previous video at the longevity of cowboys in Texas and New Mexico around 1890. And if you look at these data, you can find the minimum value is 47, the maximum is 97. The median is between 75 and 76 at 75.5. First quartile is between 66 and 68, 67. And the third quartile is between 85.5 and, between 86 and 87. So that's 86.5. So here's your 5-number summary. Now your IQR is about 20, and 1.5 times that would be 30. If you go down 30 below 67, you're going to get well below the minimum. And if you go 30 above 86.5, you're going to get well above the maximum. So there are no outliers in this data set. And if you want to draw a box plot of these data, it's pretty simple to do. Make sure you have a title. In this case, longevity of 32 cowboys in Texas and New Mexico circa 1890. Have an axis with a label. This is longevity measured in years. It extends from 47 years to 97 years. Those are our minimum and maximum values in our data. And then we have our box in the middle, which extends from the first quartile 67 to the third quartile 86.5. The median here is 75.5. Since there are no outliers, we just extend the whisker all the way out to the left to the minimum from the first quartile and all the way out to the right to the maximum. Now you don't have to put min Q1, median Q3, maximum in your graph. It's understood when people see a box plot, that's what they're looking at. And it's nice to have the 5-number summary somewhere in the neighborhood, but you don't have to put it in the actual graph itself. And that might save you a little bit of clutter if you can avoid putting that in the graph. Here's another example. We have a stem and leaf display right here of the population of the 50 states in Washington, D.C. and millions of people. This is based on the 2000 census. And as you can see, there are a lot of states that have about 1 million people. 5 have 2 million, etc. And then there's one way up here that has 34 million. That's California. And here's your little key that says what the population, what that value, what that expression right there represents. Now you can find the median and the 5-number summary from this stem and leaf display. The median works out to be the 26th observation from the bottom or from the top, since there are 51 observations altogether. And that's right there. That's 4 million. The first quartile is right here. It's 1 million. Third quartile is in here at 6 million. And the maximum is 34. So your 5-number summary looks like this. The minimum and the first quartile are the same. And here's your median, Q3, and maximum. Now, if you want to determine if there are any outliers, it's obvious there are no outliers at the low end, because the minimum is the same as the first quartile. So you're not going to have to worry about going outside the fence there. But on the high end, there's a possibility that we have some outliers. The upper fence in this case, Q3 plus 1.5 times the IQR, is 6 plus 1.5 times 5. And that's 13.5. And so any value that's above 13.5 is going to be an outlier. And we have 4 of them in this data set. We have 16, 19, 21, and 34. California, Texas, New York, and Florida. The highest value in the data set that is not an outlier is 12 million. So when you draw your box and whisker plot, you're going to want to, if you do a modified box plot, make sure you have a title, make sure you have an axis with a scale. You only need to extend with a label and a scale. You only need to extend the scale from the minimum value to the maximum value. Here is our box, first quartile, median, third quartile, and then we extended the whisker on the right side out to 12, which is the highest value in the data set that's not an outlier. You don't extend it out to 13.5, don't extend it to the fence, only extend it to the most extreme value that is not an outlier. And then we have the outliers 16, 19, 21, and 34. If you want to draw one of these on your calculator, it's quite simple to do. Go into Stat and enter the data. Now, I use these data right here, and since I have 13 ones, instead of typing them 13 times, I just typed 1 once, and then over here in the second list, I put the frequency 13. I had 2 as a value in my data set, but it occurred 5 times, so I put the frequency of 2s there, and then I had 7 3s, and 5 4s, and 4 5s, 5 6s, 1 7, etc. That saves a little bit of typing. It's a marginal difference, but it can be helpful in some situations to do that. And then once you have your data in, you can quit, go to Stat Plot, select the plot, make sure it's turned on. If you're drawing a modified box plot, this is the one you want right here. Not this one. This is the regular box plot that doesn't show the outliers. This is the modified box plot that does, and that's the one we want in this case. My X list, my data values are in list 1. The frequencies of those data values are in list 2. And then I'm going to use this mark right here as the mark for the outlier. You could choose a plus sign or a dot also, but this one is easier to see if the data set's not too big. And then you can just zoom 9, and the calculator will draw your modified box plot. And you can see we have the box over here on the left, the whisker extending out to 12, and then we have these 4 values that are outliers in the picture. So it's pretty nice. If you want to determine if a data set has outliers, instead of using the outlier rule, if you're in a hurry, for instance on your AP exam, you might just want to draw the modified box plot and see if the picture contains outliers, and then you know. Okay, so it might save you a little bit of time in a situation like that, but it's always good to find the fences and then make a comparison between the fences and the data values to determine if you have outliers. That is the best way, but it's sometimes a little bit more time consuming than drawing one of these on your calculator.